Now we'll be talking about the daily pressure variation in different latitudinal position on Earth. From what we have learned so far, we might expect to see the surface pressure dropping as the air temperature rising, and surface pressure is rising when air temperature is dropping. So this is the vice versa inverse relationship between surface pressure and the temperature. So over large continental area, especially if we are looking at southwestern United States in the summer, a hot surface air will be accompanied by surface low pressure, and likewise a cold Arctic air in the winter will be accompanied by the surface high pressure. So that situation happens in the United States. If we are looking at in the tropical region, for example, the pressure rises and falls in a regular pattern twice a day. And this regular pattern, if we look at the pressure fluctuation on this slide, maximum pressure occur in and around 10 a.m. and 10 p.m. and minimum pressure will occur 4 a.m. and 4 p.m. The largest pressure differences, about 2.5 millibar, occurs near the equator. It also shows up in the higher latitude too, but when it's a much smaller amplitude, this happens. This daily or diurnal fluctuation of pressure appeared to be due to the primarily to the absorption of solar energy, solar radiation, which is absorbed by the ozone layer in the stratosphere, in the upper atmosphere, and also this daily fluctuation also causes by the water vapor in the lower atmosphere. So the warming and cooling of the air creates density oscillation. Oscillation means fluctuation, and this density oscillation we know as thermal or atmospheric tides that shows up as small pressure changes near the surface. In middle latitude, surface pressure changes are primarily due to the large high and low pressure area that moves towards or away from a region. Generally, we can say when an area of high pressure approaches to a city, surface pressure of the city usually little rises. When it moves away from the city, the pressure usually falls a little bit. Likewise, an approaching low pressure causes the air pressure to fall, and one moving away causes the surface pressure to rise. So this is the situation that happens in mid and high latitude. So we know the temperature and the pressure relationship. Also we have learned that the differences of temperature and pressure relationship and fluctuation in terms of the latitudinal position.